So today I'm going to continue the final exam review. This is part 3. So problems 29 through 42. So problem number 29. The question is, suppose that a polynomial function of degree 5, so the degree is going to be 5, the minimum possible with rational coefficients, 4, negative 2i and 4 plus I as zeros. Find the remaining zeros. So we are given the zeros as 4, negative 2i and 4 plus I. So since the degree is 5, we have to have 5 zeros. So we can find the rest of the zeros because we are given negative 2i is the 0 means positive 2i is also 0. And 4 plus I 0 means 4 minus I also zeros. So we got all the 5 zeros. So the zeros are 4, negative 2i, 2i, 4 plus I, and 4 minus I. Okay. Next, problem number 30. There are two graphs given. We have to find the polynomial function. For each polynomial function, we have to find the minimum possible degree, the zeros, and the multiplicities of the zeros, and you have to say if it is even or odd. So part A, there are two turnings. If there are two turnings, you have to add 1 to the degree, so it's going to be 2 plus 1. There are two turning points. So the degree is going to be 2 plus 1. And the zeros. If you look at the graph, the x-intercepts, the points on the x-axis are the zeros. So the zeros are negative 2 and 0 and 1. There are 3 zeros. And the multiplicities. The multiplicity for negative 2, it's crossing the graph, so it's going to be odd multiplicity. We don't know the degree. And 0, it's crossing again, so the multiplicity is going to be odd. And for 1 also it's crossing, so it's odd multiplicity. You can write odd multiplicity, or let me write the other way. Only if it just touches the graph, it's going to be even multiplicity. So let's do B. There are how many turning points we have in the graph? So the graph goes like this. So there is 1 turning point, 2, and 3. So the degree is going to be 4. And let's write the zeros and the multiplicity. So this is zeros are 1, 2, 3 zeros. So they are negative 5, 0, and positive 5. So there's negative 5, 0, and positive 5. And negative 5 is crossing, so it's going to be odd multiplicity. And if you look at the 0, the 0 is just touching, it's not crossing, that's even. And then again, positive 5 is also odd multiplicity. So next, problem number 31. It's a word problem. It's given when a person gets a single flu shot, the concentration of the drug in per liter after T hours in the bloodstream is modeled by the equation f of t equals. This is the model of that equation. Now we have to find the horizontal asymptote of the function f of t and interpret the meaning of this. Okay, so always the horizontal asymptote is we have to find the n and the m, which is the degree of the numerator and the degree of the denominator. Degree of the numerator is 1 because the t to the power is 1, and the degree of the denominator is, which is n, and the degree of the denominator is 2, which is m. Since n is less than m, y equal to, or here it's t equal to 0 because the variable is different here. So t equal to 0 is the horizontal asymptote. Now what does that mean? That means the concentration of the flu medication in the bloodstream approaches 0 as time increases. As time increases, or as time goes up, you have to interpret the meaning of this horizontal asymptote. The blood approaches 0. Okay, that's what it means. Next, number 32. There are 3 parts, 3 questions. We have to find the horizontal asymptotes and the vertical asymptote if they exist. Okay, so let's first write we are given r of x equals 5x minus over 2x minus 1. So first we can find the vertical asymptotes. For finding the vertical asymptotes, always we have to set the denominator equal to 0. This 2x minus 1 equal to 0 and solve for x. So we get 2x equal to 1, divide by 2, so x equals 1/2 is the vertical asymptote. To find the horizontal asymptote, we have to find the degree of the numerator. Since the degree of the numerator is n is equal to m, which is 1, 1, both are 1. So y equal to 5 over 2. The coefficient of the leading coefficient is the, we have to write the leading coefficient of the numerator by the denominator. Next part B, we have q of x equal to 7x over x squared minus 1. So the vertical asymptote, as before, set the denominator equal to 0. So we have to find the x. X is going to be square root of plus or minus. So we get x equals plus or minus 1. So there are 2 vertical asymptotes. And to find the horizontal asymptotes, what is the degree of the numerator is 1 and the denominator is 2. If it is less than the denominator, then y equal to 0 is the horizontal asymptote. Okay. Next part C, there is one more, g of x equals 3x plus 2. So to find the vertical asymptote, set the denominator equal to 0 and solve for x. So x equals negative 2/3 is the horizontal asymptote. To find the vertical asymptote. The horizontal asymptote, the degree of the numerator, which is n, is 3 and m is 1 because there's no power. And if n is greater than m, there is no horizontal asymptote. Okay. Next one, number 33. We are given a word problem. A large group of students is asked to memorize a list of 60 Italian words, a language that is both unfamiliar and phonetically foreign to them. The group is then tested regularly to see how many of the words are retained. And it's given by the function w of t equals 6t plus 25 over t, where the w of t represents the number of words retained after t days. Find the horizontal asymptote. So basically, and we have to find the horizontal asymptote and describe the meaning related to the context. So the horizontal asymptote here, the degree of the numerator is the same as the denominator. So w is the variable here. W of t is going to be 6, the coefficient. That is, it's the coefficient of the numerator and then the denominator. So we get w equal to just 6. This is the horizontal asymptote. And what is that meaning? Most students will remember only 6 words for life. Okay, so that is number 30. Okay, so number 34, we are given functions. We have to find the domain. So the first one, f of x, is the best way to find the domain. You can put it on your calculator and you can see. However, for square root function, the expression inside the square root should be greater than or equal to 0. That means it has to be positive. So you set it like this. Always take the quantity inside the square root and set they are equal to greater than or equal to 0 and solve for x. So we get x should be greater than or equal to 5 over 3. And the question is, we have to write them in the interval notation. So this means 5/3 comma infinity. So the domain is 5/3 comma infinity. Part B, we are given f of x equals 2x squared plus x plus 10. And if you can enter on your calculator and see, the domain is going to be negative infinity comma infinity. And C, we are given f of x equals 2 over 3x plus 2. So it's a rational function, so the denominator cannot be equal to 0. So then solve for x. So 3x cannot be equal to negative 2 and divide by 3. So x cannot be equal to negative 2/3. So basically the domain is going to be negative infinity to negative 2/3 union negative 2/3 to infinity. And D, part D is we are given f of x equals e to the power x plus 2 minus 3. So for any exponential function, the domain is always going to be negative infinity to positive infinity. The last one, f of x equals again for logarithmic functions, if it is positive, the log function has to be always positive. That means 3x plus 4 should be greater than 0. Then solve for x. So 3x should be greater than -4. So divide by 3. -4 over 3. So x is greater than -4 third. So the domain is going to be -4 third comma infinity. So this is the domain for each problem. And number 35, we are given f of x equals, use the equations. By you have to graph, I'm not putting the graph, so I'm just writing the asymptotes. The vertical asymptote is set the denominator equal to 0. So add 2, so x equals to 2 is the vertical asymptotes. The horizontal asymptotes is the y equal to 3. And number 36, you have to write the domain. The domain is from the graph -infinity to infinity, and the range is -infinity to 3. And it's not a function. It's not a one-to-one function, because if you do the horizontal line test, because the graph goes like this, when you do the horizontal, it's going to meet more than 1, so it's not a one-to-one function. And then B is, the domain is -infinity to infinity. The range is -3 comma infinity. Again, it's not a one-to-one function because the function is like V-shaped, so it's not one-to-one function. So I'm going to leave the rest of them to you. You can check that. Then I'm going to do a couple of more. In 37, I'm just going to do only one. You can try the rest of them. So f of x equal to 3x to the third plus 2. You have to find the inverse. So first replace the f of x by y. And then exchange the x, y, and the x equal to, and then solve for y. So we're going to subtract 2 first. So we get x minus 2 equals 3y squared, and divide by 3. We are getting solving for y. So it's going to be minus 3 equals y squared, and y is going to be plus or minus. Sorry, I didn't put 3. So it's not plus or minus, I'm sorry. So it's going to be 1 cube root of this expression. Okay, so I'm going to leave it, the rest of them, for you to practice. And then number 39, I'm doing only one part. Number 39, I'm going to do find the vertical asymptote domain. So I'm doing a, f of x equals log of 2x minus 8. To find the domain, it has to be 2x minus 8 should be greater than 0. Solve for x. So you get 2x is greater than 8. Divide by 2. So x is greater than 4. That means 4 to infinity is the domain. And the range is going to be, the range is always going to, the range for this function is going to be -infinity to -infinity, positive infinity, sorry. And then and the vertical asymptote is x equal to 4. Okay, so number 4, we have 40. I'm going to do the 40, convert the equation to So logarithm, so it's going to be log so log 4 times 2.8 equal to x. And then number 41, we're going to simplify log 25 log log with base 25 of 5 is going to be 1/2. And b is log a to the power log a with base a, it's going to be just 5 because they get cancelled. And log square root of fifth root of a is going to be just 1/5. And d is log with base a, it's going to be negative -5. Okay, and the last problem today is number 42. You have to write the SA, we have to expand. So it's going to be, you have to apply the product rule first. Okay, so if you combine the answer, log 1, this is going to be 1. So we are applying quotient, product, and the power rule, all the rules here. So that's how we expand. So I'm going to cover the rest in my other part. So I'll see you.